Good morning or good afternoon, everybody. I know that you've been studying Spearman's rank correlation coefficient, and today I want to talk to you about Pearson's correlation coefficient. To start out, I want you to take a look at the data that you have here in front of you. If you notice, this data is not ranked data. This data has the variable age in months. This is for, say, a human child, baby, and then their height in inches. This data is not ranked. These are two separate variables, and I bet we can safely assume that these variables are related to each other, that you can probably see in the table that as the age of the baby increases, their height increases. We're not surprised by this. What we want to figure out is how closely are these two things related, or how strong is the relationship between a baby's age in months and its height in inches. We can use Pearson's correlation coefficient to figure this out because it's not ranked data. And so if we look at the next page, this is Pearson's correlation coefficient. It looks a little bit more complicated than Spearman's, and it is because we have a little bit more data involved, but it's not impossible. So if we look at some data here, to find Pearson's correlation coefficient, we have all these different parts. Okay, we're going to just have our x data and our y data. We have x bar on top. That means the mean of the x data. We're going to be subtracting the x data and the mean of the x data and then squaring it. We have y with the bar on top. That's the mean of the y data. Going to be subtracting those and squaring it, and then going to be multiplying the two parts when we're subtracting. All those different parts go into the formula. If I start by doing the sum, remember this sigma symbol means sum. So we have 1 plus 2 is 3 plus 3, this is 6. 2 and 4 is 6, and 6 is 12. Then we need the mean of the x data. Well, 6 was the sum divided by 3 values, so the x mean, 6 divided by 3 is 2. Might as well find the y mean at the same time. That's 12 divided by 3, so the y mean, 12 divided by 3 is 4. Then we're going to start to use this. We're going to take the x data 1, subtract the mean. Well, 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. If I find that sum, that's 0. And then I want to square each of those. Well, negative 1 squared is 1. 0 squared is 0. 1 squared is 1. The sum of all that is 2. Then I'm going to take my y data and subtract the y mean. So y, 2 minus 4 is negative 2. 4 minus 4 is 0. 6 minus 4 is positive 2. The sum of that is 0. If we square each of those, negative 2 squared is positive 4. 0 squared is 0. 2 squared is 4. The sum of that is 8. If I just want to multiply without the squaring, then I'm going to multiply just this part subtracting with just this part for each data point. Negative 1 times negative 2 is just positive 2. Obviously 0 times 0 is 0, and then 1 times 2 is also 2, and when I add that together, it's 4. So using these columns, we've created a bunch of information here. If we take some of this information back to our Pearson's correlation coefficient chart, the top of the formula is the sum of this column. Let me get another color. So we're going to want this sum to go on top, 4. If I plug this in, the sum of that column, so R is equal to 4 over, I'm going to have the square root of the sum of the x column times the square root, the sum of the y column. Well, let's double check and see what those were. The x column squared was 2, and the y column squared was 8. So I'm plugging in 2 and 8. If we go ahead and complete this, well, that's still 4 on top. The square root of 2 times the square root of 8 becomes the square root of 16. The square root of 16 is 4, so we have 4 over 4. Well, that's just 1. So the correlation coefficient in this case for the small example that I showed you, whoop, wrong way. The correlation coefficient for this data set, 1, 2, 2, 4, 3, 6, is actually a perfect correlation of 1. Pearson's correlation coefficient, like Spearman's, can go from -1 to +1, this being perfectly matched, perfect, strong relationship. Strong positive. Anything above, say, a 0.8, we can call a strong positive. In the middle, 0 would mean there's no relationship. Close to 0 would be a weak relationship. And then -1 would be a strong negative relationship. Strong negative relationship. Well, this formula is pretty involved, though. If you go back to looking at this whole chart thing, that was probably a little confusing for you. If we had 4 pieces of data, it's that much more involved. If we want to use the data from the very beginning of the baby's heights and their age, then that's a lot more data, and it probably isn't going to work out as neatly as these numbers did with nice whole numbers. So you may be pleased to know that there is a tech tip on how to do Pearson's correlation coefficient on the graphing calculator. Hooray. So what I want to do is show you how to do this with the graphing calculator, and in class you'll get a copy of this tech tip so that you'll be able to follow along on your own. So I'm just pulling up the calculator, and what I've done is taken that baby's age and height data, and I've put it into a list already. 2 lists. Here's their age in months and their height in inches. Just like when we use any data, we got to put it into lists. Now, an important step in finding Pearson's correlation coefficient is to turn on a certain diagnostic tool that allows us to analyze the strength of the relationship. So one of the first steps you want to do when you turn your calculator on is to make sure that the diagnostic tool is turned on. So to do that, you're going to hit second and then 0 for catalog. And you're gonna click down until you find diagnostic on. And what this does is just turn on a certain part of the calculator so it knows to do a certain calculation. So we're going down to the D's. There's off and there's on. So we want to make sure it's on. Diagnostic on. Why doesn't it say it on that side? Diagnostic on. We're going to hit enter. It's going to go to that screen and just hit enter. So it says done. Diagnostic is on. We can go back and double check that our data is in the calculator. There are lists. To calculate Pearson's correlation coefficient, you go back to stat, over to calc, and it's like we're finding the equation of the line. So we're going to go down to number 4, linear regression, enter, and you want to enter the list that it's in. So this data is in list 1, comma, second, list 2, and then enter. And what you're looking for, doesn't let me do the red pen, is the R that's over here. R equals 0.958. That R tells us the strength of the relationship between the baby's ages and their heights. And hopefully you're saying to yourself right now that 0.958 is very close to +1. So that means that is a very strong positive relationship between babies' ages and their heights. Let's go back to this. So we found that the R, Pearson's R, was 0.958, so that this relationship shows a strong positive. Make sure that you ask for the tech tip in your math class, and hopefully this will help you learn how to find the Pearson's R correlation coefficient, which measures the strength of the relationship between two variables.